My name is Amanda Graham. I am the Academic Director for the Irving Institute for Energy and Society here at Dartmouth College, and it has been our pleasure to organize and coordinate this series. We've been doing this now for almost a year and a half, where we feature young scholars in energy and society every 2 weeks. And we've had students, we've had scholars, many of them assistant professors, some graduate students or postdocs who have spoken on a wide range of topics during this past almost 18 months or so. And it's become a really wonderful place to learn about what's emerging in terms of research in this space. So thank you again for joining us today to learn from Dr. Danae Hernández-Cortés. I am going to give a little bit of an introduction to Dr. Hernández-Cortés, and then I will hand things over to her. And then after, I think 20 to 30 minutes or so, we will have an open Q&A session. And so please, when you have them, load your questions into the Q&A box whenever they occur to you. So Dr. Hernández-Cortés comes to us today from Arizona State University, where she has just joined the faculty of the School for the Future of Innovation in Society and the School of Sustainability. Her degrees are all in economics. Her Ph.D. in economics is from UC Santa Barbara. And her interests are in environmental economics, environmental justice, and the distributional consequences of environmental policy. And in pursuing those research interests, she has looked at cases both in her native Mexico as well as in California, which is the subject of her talk today. And her talk today takes its genesis from a working paper that she produced, I think for the first time in 2020. Is that right, Dr. Hernández-Cortés? With the National Bureau of Economic Research. And she'll be speaking today about the revised version of that paper, which came out just last month. And the focus here is on the challenges and opportunities of environmental markets when we're thinking about environmental and energy justice. And so with that, I hand it over to you, Dr. Hernández-Cortés, and please take it away. Thank you so much for being here.
Thank you so much, Amanda. I am very excited to be here. Let me quickly share my screen. Can you see it in full screen? Yeah, perfect. Okay, so thank you so much for having me here. I am very excited to present this paper that is, as it was mentioned before, it's a working paper. So I'm really looking forward to hearing your questions and comments, because this will greatly improve the paper. This paper is together with Kyle Meng from UC Santa Barbara. And in this paper, we're trying to look at the environmental justice consequences of environmental markets. And in specific, we're going to focus in one specific market, which is California's cap and trade program. And so the start of this paper was motivated because environmental markets have been increasingly used to regulate environmental problems. So for example, 30% of global fisheries are regulated either through some sort of market or quota. There's around $36 billion in ecosystem service payments throughout the world, and around 22% of global greenhouse gas emissions are regulated either via a carbon tax or a cap and trade program. And this is set to possibly increase after Mexico and other countries implement their own environmental markets. The key feature of environmental markets, as we all know, is that markets may change where pollution is occurring, either for greenhouse gases or for other pollutants, depending the pollutants that are being regulated through this market. By doing so, it lowers the overall cost of meeting an environmental objective. This is compared to other potential non-market alternatives like a standard or like a standard such as the renewable portfolio standards or so on. However, this reallocation due to a market can lead to relatively greater pollution concentration for disadvantaged communities, therefore creating possible environmental justice concern. This is a central tension because the same market forces that can enable cost effectiveness and that sometimes economies like from an efficiency standpoint can also alter the inequities in pollution concentrations because markets might reallocate where pollution is occurring via hotspots. This could lead to environmental justice concerns. And I know that we are all familiar with this topic, but I always like to introduce what are some of the environmental justice concerns that we can be worried about. So for example, environmental justice concern can involve many things, such as the involvement of people, of all people, regardless of race, color, national origin, etc., in environmental decisions, as well as the non-disproportionate siting of pollution facilities in communities of color, etc. One environmental justice concern is that it is very well documented that polluted places are also poorer and have more minorities than other places that are less polluted. So for example, let's look at the figure at the left. This is an area in North Carolina. And in the colors, you can go from the lowest shade of color to the highest shade of color in terms of income. And the little circles mean the location of the toxic release inventory facilities. This is facilities that emit lots of toxics. As you can see, most of the locations of these toxic release inventory facilities are located in the white or yellow areas, which mean that most of these facilities are located near poorer, near areas that are poorer than other areas in the map. Now, this is not only the case in this case in North Carolina, but let's look at the other picture in the right, and we can see in the x-axis the pollution levels that people are exposed to, and in the left axis the population share of two groups, white and black. And as you can see, black populations are located in places that are more polluted than white populations. This is also the case in California. So for example, in the case that we study, if we are plotting the poverty rates and the PM2.5 concentrations, which PM2.5 is one of the most damaging pollutants for health, we can see that places that are poorer are also the ones that are more polluted on average compared to places that are less poor. So all of this is to say that polluted places are relatively poorer and also have higher minorities than other places that are less polluted. Therefore, these intrinsic, these systematic issues can also overlap to some environmental policies, and we need to be aware of how these environmental policies could affect the distribution of pollution in these places. So there have been many environmental justice concerns over market-based policies. So for example, the first in Washington State carbon tax in 2016 and the Oregon State climate policy in 2019 were both non-passed because of environmental justice concerns. Another example of these policies that have received sorry, was there a problem with my internet?
Yes, you were frozen. And now you are dark.
Oh, sorry. Can you still see me?
Yes.
Perfect. Should I share screen again? Sorry about that.
There you go. Perfect.
Yes, thank you so much. I'm really sorry about this.
No problem.
Okay, so all of these concerns in terms of environmental justice can mean that disadvantaged communities may systematically more exposed to pollution coming from these programs than other communities. Therefore, in this paper, we are going to be analyzing what is the impact of environmental markets on environmental justice in California. So first of all, I would like to try to explain how a greenhouse gas cap and trade program may affect the environmental justice gap. This is the difference in pollution concentrations between disadvantaged communities and other communities. In the case of climate policy, the environmental justice the environmental justice effect can depend on the location of greenhouse gas emitters, their production, and the co-production of local pollutants such as PM2.5, NOx, SOx, etc. And why might some facilities generate more pollutions than others, or how can they affect environmental justice concerns? I am going to explain it in these two diagrams. So first, let's compare two facilities. One where a disadvantaged community is located upwind of a facility with a steeper marginal abatement cost. This means that this is steeper than this other line, and these are marginal abatement costs. So before cap and trade started, the difference in emissions here in the x-axis is given by this gap, the pre-environmental justice gap. After a tax is imposed on these emissions, we are expected to these emissions to be reduced. And this tax puts an implicit price in pollution. So imagine we establish this level of tax, tau, and what we get is a post-environmental justice gap of this size. So after the tax was implemented, after a tax or a cap and trade that puts a price on pollution, this is the post-environmental justice gap. Now, let's compare it to when one facility is, when the facility that we are looking at, this is the one that has a more steep marginal abatement cost, is located near a non-disadvantaged community. Therefore, this is the case. Now, pre-environmental justice gap, this is the environmental justice gap before the market occurred is this one. However, after there's a tax, the environmental justice gap is given by this case. If you compare this case versus the case to the left, you can see that the environmental justice gap in this case is decreasing, whereas in this case, it's increasing. Therefore, how the environmental justice gap will look after a cap and trade was implemented will depend on whether the marginal abatement cost facilities are located upwind or downwind of these disadvantaged communities. If steeper marginal abatement cost polluters are located upwind of disadvantaged communities, a cap and trade program may widen the environmental justice gap. Whereas in the opposite case, they are located near other communities, a cap and trade may narrow the environmental justice gap. And in these diagrams, what we're wanting to see is whether, and what our paper is going to try to see is whether we are looking in California at a case where a cap and trade is widening the environmental justice gap, or is it narrowing? And so in our paper, we are going to be investigating this case. We are going to be asking whether local air pollution concentration gap between disadvantaged communities and other communities, what we will refer as the environmental justice gap, change following the introduction of the greenhouse gas cap and trade program. And there are two very big challenges in order to try to explore this question. The first one is that we have to isolate the effect of cap and trade on emissions compared to any other circumstances or any other potential confounders that could have affected emissions and that are not related to cap and trade. The second one is that we need to map the cap and trade driven facility pollution emissions, so where the pollution is being emitted, and we have to translate this into concentrations in the communities located near these facilities. Therefore, we have to map the sources where the emissions are coming to the concentrations or the receptors. And these two steps have several challenges. The first one is the challenge number one that we're going to be calling the challenge estimating the causal effect on emissions. This means that we have to isolate all of the potential sources that could have affected emissions that are not related to cap and trade. And how are we going to do that? Well, we are going to be comparing regulated facilities versus unregulated facilities before and after cap and trade start. This will allow us to isolate other potential effects that could have changed how pollutions are being emitted that are not related to cap and trade. And this can be challenging, but we are also following some other existing studies that have done the same using causal inference methods. Now, the second challenge is trying to modeling where pollution is going. And in order to try to understand this, it will be helpful for me to explain you how sometimes we assume that pollution is moving across the space. There are two prevailing approaches in trying to assign pollution concentrations from sources to receptors. The first one is this one, the one to the left. And imagine that all of these little squares are a zip code or a county. This approach will tell us that the source, the dot here, the source will emit pollution, and the pollution will stay within the administrative boundary where it was released. Therefore, if this source is located in this square, the pollution will stay in this square. This is approach number one. The approach number two is the following. This approach assumes that pollution will travel uniformly surrounding a circle of influence or a buffer. This means that pollution will stay within the buffer and not travel anywhere else. However, pollution dispersal can be way more complicated than that. And in fact, what we're going to try to do here is to embed a pollution dispersal model, and with the first step that I described before. So in this case, we are going to calculate an atmospheric transport model that will allow us to map all of the existing sources in California into the possible concentrations that could be affected in the whole state of California. And I will give more details in a second. And I will also like to emphasize a preview of our results before I get into further detail in case some of you need to step out of the presentation. We showed in our paper that cap and trade program caused a change in the trend of greenhouse gases and local air pollution emissions for the sample facilities that we are studying. We calculate that between 2012 and 2017, cap and trade reduced emissions by around 3 to 9% per year across greenhouse gases and criteria air pollutants. We also found that the program reversed a widening environmental justice gap for all of the pollutants that we are examining. And this translates into a return of the environmental justice gap to roughly 2008 levels. So for example, this is a summary of our paper that I will describe in a second. We find that the difference in pollution concentrations between disadvantaged communities and other communities was increasing before the program. However, we find that after the program took place, that trend completely reversed, meaning that disadvantaged communities experience a higher reduction in pollution concentrations compared to other communities throughout California. So now I will give you a little more detail on how we were able to find these results. So let's start with a little bit of background of California's greenhouse gas cap and trade program. This program is also called AB 32, and it is stated that the statewide greenhouse gas emissions need to be by 1990 levels in 2020. This program was passed in 2006. And it's set to begin in 2013. This established the world's second largest greenhouse gas cap and trade program in the world, only after the European ETS. This program covers around 85% of the statewide emissions from stationary point sources, and there are a couple of key institutional features. First one, the cap and trade facility eligibility. All of the eligible facilities are those that are emitting more than 25,000 tons of CO2 emissions per year. These facilities are said to be regulated in 2013, but one of the drawbacks of this policy is that it's very hard to isolate because cap and trade was not the only part of the California climate policy. There were other multiple complementary policies that could have also affected how cap and trade developed. These two complementary policies in specific are the renewable portfolio standards for electricity generators and the low carbon fuel standards for refineries. So these two multiple complementary policies are important because we will have to try to isolate the effects of cap and trade from these other policies that could have affected emissions of greenhouse gases and other pollutants. Now, how do we get the data? We are using two main sources of data. The first one is the California Air Resources Board facility by year emissions. This data set contains information of all of the emissions from all of the facilities in California, not only the ones that are regulated. We obtain information of CO2, PM2.5, PM10, NOx, and SOx from regulated and unregulated facilities. This allows us to construct a data set of emissions before and after cap and trade started. We also obtain information on the location, sector, and stack characteristics of these facilities. Now, in order for us to analyze these questions, as I've been telling you before, we made two important sample restrictions. The first one is that we excluded electricity generators and oil refineries because they were also regulated by other complementary policies. The second restriction is that we made a size compatibility restriction. This means that we excluded facilities with average greenhouse gas emissions that are above the 75th percentile. This will allow us to try to isolate the impacts of the policy without only comparing the big emitters versus the small emitters throughout the state. The second data set that we are using is the definition of disadvantaged zip code in California. This definition is given by the Senate Bill 535, and this definition classifies disadvantaged communities if a part of the zip code contains a census tract or more communities that are classified as the most vulnerable communities in terms of economic vulnerability, environmental vulnerability, and health vulnerability. This definition is really important because it's also the basis of the action revenue spending of California's cap and trade program. So this means that all of the revenue that is collected from this cap and trade program has to be spent in several things, but 25% of it needs to be spent on disadvantaged communities. This definition is based on pre-cap and trade characteristics, and this is important, and I will explain you why in a couple of slides. Now, how do we go from emissions to concentrations? The first step is to try to isolate the cap and trade driven emissions. This is, we're going to compare regulated facilities versus unregulated facilities before and after cap and trade started. So here, if you see in this rectangle, you see all of these points are all of the cap and trade regulated facilities. And so we're going to isolate these, we're going to isolate the emissions coming from cap and trade by comparing the regulated facilities versus the unregulated facilities. Now, the second step, we are going to obtain these emissions that are coming from the program, and we are going to introduce them in an atmospheric transport model. This will allow us to see how pollution dispersion is traveling across space using prevailing wind patterns across California. The third step is to estimate the change in the environmental justice gap. As I have said before, it is the difference in pollution concentrations between disadvantaged communities and other communities before and after cap and trade started. So with these three steps, we are going to try to estimate whether disadvantaged communities were more exposed to pollution concentrations than other communities after the program was implemented. Now, this slide contains a little bit more detail on how we're doing this. I will explain it in very simple terms. Again, we are going to be comparing regulated facilities versus unregulated facilities after 2013. That is when the program started. This is giving us a using this approach, we need to assume something very important. That is that all of the differential emissions that could have happened will have continued if California's cap and trade was not implemented. So this is a very important identification assumption that we are going to have to rely on for doing this part of the paper. Now, the second part of the paper, the second step to isolate these effects is to model pollution dispersal. And to do so, we are going to use HYSPLIT, which is a particle trajectory model that was developed by NOAA and incorporates time-varying meteorological conditions and topology in California. We are going to be running this atmospheric transform model for all of the facilities in California for every 3 hours between 2008 to 2017, according with the weather patterns that were occurring at that time. This will allow us to calculate around 2 million trajectories, which took a very long time to run. But we think it's important because of how pollution is traveling across space. However, it has a big limitation. This is that there's no atmospheric chemistry. Therefore, possible secondary release of particles are not accounted in this methodology. Now, the third effect, and is what we are really interested in knowing, is the difference in pollution concentrations between disadvantaged communities and other communities before and after cap and trade started. And to do so, again, we are going to compare the pollutions coming from cap and trade, as we explained in the first 2 steps, in disadvantaged communities using this atmospheric transport model. And we're going to compare disadvantaged communities versus other communities before and after cap and trade started. So now to our results. First, I am going to show you how cap and trade, whether cap and trade actually decreased greenhouse gas emissions and local air pollutant emissions after it was implemented. When we look at this step, we are going to be looking at this second row, and we see that cap and trade actually decreased the emissions of CO2, PM2.5, PM10, and NOx. We don't see a decrease in SOx. We estimate that during 2012 and 2017, greenhouse gases and criteria air pollutant emissions fell by about 3 to 9% per year after cap and trade was implemented. This meant 3.2 million tons of CO2 equivalent abated across all of the sample facilities, which again, we consider this a lower bound, given that we are only looking at these specific facilities and not to the universe of facilities due to our sample restrictions. Now, our second result is trying to see how our model is trying to predict the pollution that is being experienced in California. And again, what we're trying to obtain in our model is all of the pollution concentrations coming from the program, not all of the pollution in California. So we should expect that these ones are correlated, however, that they are not perfectly explained. When we do this, we explain about 86% of PM2.5 concentrations in California, about 62% of PM10, and to a less extent, the emissions in NOx, in SOx in California. Therefore, we think that our model is estimating these pollution concentrations throughout California. Of course, there's no perfect fit. However, we think that it's a good approximation. Now, the third step, which is the environmental justice gap. First, let me show you how disadvantaged communities were experiencing pollution concentrations before cap and trade started. If we compare disadvantaged communities versus other communities, we can see that disadvantaged communities are in fact experiencing almost 3 times as much pollution concentrations than other communities. So here you see the pollution concentrations coming from the program uniquely. between disadvantaged communities and other communities. And as you can see, they are almost 3 times as much in disadvantaged communities compared to other communities. Now, what is the effect of cap and trade on the environmental justice gap? As I told you before, we find that before cap and trade started in 2013, there was an increase in the environmental justice gap between disadvantaged communities and other communities. This means that pollution concentrations were increasing more in disadvantaged communities than other communities before cap and trade started. However, we find that after 2012, this reversal totally changed, meaning that disadvantaged communities benefited more from the reductions of pollutions coming from cap and trade program. This means that environmental justice increased after cap and trade started compared to what was happening before cap and trade started, therefore increasing environmental justice across California. We see the same in the case of PM10 and other pollutants such as NOx and SOx. However, SOx is a little bit more noisy. We also see that there's a lot of spatial heterogeneity. So here you can see if it's in blue, this means that there was a decrease in the environmental justice gap. If it's in red, it means that environmental justice didn't decrease, the environmental injustice increases. And we see that, in fact, there are some areas near Los Angeles where where pollution increased in disadvantaged communities compared to other communities, meaning that this decrease was not uniform in all California. However, we find that most of California's disadvantaged communities actually experience a decrease in pollution concentrations coming from the program. Finally, our results are robust to several other sample limitations and other assumptions that we tested, meaning that our effect, that the disadvantaged communities experience a higher decrease in pollution concentration, decrease in pollution concentration is robust to many other sample restrictions and other considerations. We also looked at many other concerns that you could be thinking. And in particular, I want to emphasize one thing that we changed, which was that we, instead of looking only at zip codes, we also looked at census tracts just to try to compare how our measures will compare if we look at census tracts compared to zip codes. And we find that actually, when looking at census tracts, the effects are actually larger, meaning that disadvantaged communities is the same result, that disadvantaged communities are benefited more from this program than other communities. Finally, our paper also compared our results to other prevailing approaches. And what we find is that our result is actually better at trying to predict these environmental justice changes compared to other results. Compared to other approaches. And indeed, if we had used other approaches to try to explain this, we will have found opposite results. So to conclude, California's greenhouse gas cap and trade program lowered the greenhouse gas and criteria air pollution emissions in California. It also reversed a previous widening environmental justice gap for PM2.5, PM10, NOx, and SOx. And we found that by 2017, the environmental justice gap returned to roughly 2008 levels. Our paper also demonstrates how integrating physical processes with econometric techniques is very important for evaluating this type of policies. However, I will also like to emphasize some caveats that our paper had. So for California, the environmental justice gap effect compares pre and post 2013. We are not comparing the implementation of other hypothetical alternative climate policy. We can only compare before and after, which basically means that we are only comparing a cap and trade world versus a not cap and trade world. We cannot compare against an alternative hypothetical to another policy that we could have used, such as a command and control or other policies like renewable portfolio standards. Also, the environmental justice gap is still there. it only reduced to 2008 levels. More importantly, a full distributional analysis will require analyzing the health outcomes and the cost burden of this policy. Not only, it doesn't necessarily mean that all of these changes in concentration translated into better health outcomes. And indeed, we are currently trying to analyze whether the decrease in concentrations also reflected better health outcomes for disadvantaged communities. So please stay tuned for this, for that research as well. But more broadly, environmental markets may not always reduce environmental justice gap. And to try to examine this, we need more theory that allows us to characterize whether market-based policies can either worsen or improve environmental justice concerns for many other cases, not only for California. And I would like to finish saying that environmental justice problems need environmental justice policies. This means that if we want to really achieve an equitable transition, we need to incorporate some environmental justice policies that try to address systematic exposure differences between disadvantaged communities and other communities. And without anything else to say, I really want to say thank you for inviting me, and I'm really looking forward for all of your questions.
Thank you so very much, Dr. Hernández-Cortés. I really appreciate your presentation today. I have questions. We have questions starting to come in. If you want to go ahead and unshare your screen, and we can have a little bit of conversation with the folks who are starting to add questions to the Q&A. So please, if you have a question, please plop it into the Q&A. So our first question is from Dr. Philip Chernock, who is a visiting Fulbright scholar at Dartmouth College. Thank you, Philip, for your question. And he asks, could you please describe with an example the mechanism of how cap and trade can affect the spatial distribution of pollution? If cap and trade applies to all of California, then there may be a reallocation of resources outside the state. But why should pollution sources move to or from disadvantaged communities under the same cap and trade system? And he does say great research, and thank you. So if you respond to Philip's question, that would be great.
Yes, thank you. Thank you so much. This is a really good question. So what we think that is happening here in the case of cap and trade can change where pollution is being emitted because some facilities with the lowest abatement cost might be decreasing more compared to other facilities that have higher abatement cost. This means that.
Could you speak for a minute about
yes.
Costs, right? So I think that
yes.
that marginal abatement cost, we might need a little bit of clarification of what that means.
Yes. The marginal abatement cost means that how costly it is for you as a facility to reduce your emissions. For example, if you are a very, very clean facility, it might be very expensive for you to reduce your emissions because you are already very clean. However, if you are a not so clean facility, even improving a little bit in your technology might mean that your emissions will be decreasing. This means that your marginal abatement cost is lower than this other facility that is already very clean. So what cap and trade does in theory is to reallocate where pollution is occurring to facilities that are better at trying to reduce emissions. So what we're concerned in this case is that these facilities that are more polluting are also located near disadvantaged communities. And because they are, it is cheaper for them to emit things, they might emit more than in other facilities. So this is the reallocation that we are trying to examine. Now, it is a very good point that this reallocation might change to other states. We cannot look at that in our setting because we don't have data of other states. However, that is a very good point that this reallocation could lead to other types of inequalities if we look at other states indeed.
Thank you so much. for that. And I think that was a really helpful clarification. I'm not sure if we can, I know that I saw Professor Aaron Mansour from the Tuck Business School raised his hand. I'm not sure if we can bring your voice into the mix, Aaron. So if we can't do that, Stephanie advised me if we can, but if we can't do that, oh, there we go. Aaron, please.
Great
question.
Yeah, thanks. I appreciate the Q&A, but I prefer to ask my questions. So thanks. So first of all, great paper. I'm a big fan of this paper. It was great to have you able to present it. I had a couple questions, as you might imagine. So I did some work long ago on the reclaim market in Southern California, and I have not been tracking how that has been performing. But I might imagine, especially in the case of your analysis of nitrogen oxide emissions, that the markets interact. And I was wondering if you could say a little bit about that. So just for everyone else online here, the reclaim market is a cap and trade system for nitrogen oxide emissions in Los Angeles, so not all of California. But it might be interesting to think about how these two cap and trade systems interact.
Thank you so much for this question. And yes, your papers have actually really influenced how we have looked at environmental markets and the distributional consequences. So I'm very excited to finally be able to discuss these two papers together. So thank you so much for the question, Erin. And well, this is a very good question. And indeed, in our paper, we are trying to we are doing another sample restriction when we look at when we try to look at these concerns, when we're trying to look at these concerns, indeed, we haven't fully examined whether these two markets interact, but it's definitely one important question that we could try to address. One thing that we did do that is based on the studies that are also looking at the reclaim market is trying to divide facilities by the ones that are in non-attainment versus attainment in the terms of the Cleaner Act. And we find that actually stronger results when we do that division like you did in your paper. So so that is the only things that we have looked into with regards to possible general equilibrium effects. However, that is the question about looking at reclaimed facilities is really good. So I should look at it more carefully, or maybe only look at facilities within Los Angeles to try to look if something is happening. But it's definitely a very good question. Thank you.
Great, thank you.
And Erin, did you have any other questions to ask of Dr. Hernández-Cortés?
Sure, I just didn't want to take all the time, but yeah, one other question. You had mentioned that the electricity and the oil refiners were excluded, and I get that from identification perspective. It makes sense. On the other hand, they are massive contributors to all these pollutants, and so I was wondering if you could say a little bit about anything you've done to kind of explore how they changed over this time.
I'm really glad you asked that question, actually, because I also, I mean, what I was interested in understanding was when you take those ones out, what was left right in your sample? And so if you could characterize, you know, the elements that were in your sample as well as responding to this, to Erin's provocation there, that would be great.
No, these are very good concerns. And indeed, I think that we try to isolate the effect of cap and trade for identification purposes, because it's really hard to introduce more facilities and try to look at that when you have other complementary policies. But this is true. We are looking at smaller facilities that are not as polluting as other facilities. However, we also show results in the paper. We also show results for all of the facilities, and we actually find the stronger effects when we look at all of the facilities. So not when we only include our samples. So this, in fact, shows that the impact is not only happening for the facilities we're looking at, but when we expand to more facilities, we also see the effects, and they are actually larger.
The effects with regard to pollution in general, or the effects with regard specifically to narrowing the EJ gap?
The effects with regards narrowing the environmental justice gap.
Got it. Okay.
Yeah, but that's a great question. Thank you.
Great. Thank you. So we're open for business for additional questions. So Professor Mansour, if you have additional questions, please feel free to share them at this time. But folks, if folks have them, either raise your hand, just like Professor Mansour did, or plop them into the Q&A.
Yeah, unfortunately, I need to run to another meeting, but thank you so much. I really appreciated your presentation and your responses. Take care.
Thank you so much for the comments too.
All right, bye.
Thanks very much. So I wondered if you could share with us a little bit of insight on how your paper evolved between the original May 2020 publication, which had great impact, right, in various circles. Maybe you could describe, the process of the experience that you had with that initial release of the paper, and then the process you went through for the revisions that came through in September.
Yeah, thank you so much for that question. And indeed, when we got the paper out there, I think that we didn't consider many other things that could have been happening. And indeed, when I explained you the graphs and the differences between the marginal abatement cost facilities located with respect to disadvantaged communities, we didn't have that part in the paper before, but we thought that it will be easier to settle the mechanism, to try to explain the mechanism, to add that part and try to explain what was happening. On the same way, our first version of the paper was actually looking at all of the facilities, not only the ones that we were looking at, but we were including the electricity generators as well as the refineries. However, we received a lot of comments from other colleagues telling us that the effects that we are finding could be due to either cap and trade or these other policies. So we said this is totally true. So we try to isolate those effects as well. So that is something that it definitely changed from the first version to this newer version. We also received some comments from environmental justice advocates telling us that even though we're looking at zip code level data, looking at census tract might actually be better because census tracts are more reflective of actual communities than zip codes, are actually smaller, and you are able to identify communities better. So indeed, we changed that definition and we try to look at census tract, which when you try to look at that, the result is actually cleaner, and you are actually able to demonstrate that in fact, these pollution reductions are also present in census tracts, not only in zip codes. Finally, another thing that that people were concerned is in our definition of disadvantaged communities. And indeed, in order to try to explore other definitions, we looked at other alternative definitions, such as the share of people that are either Black or Hispanic in each census tract. And we try to look at alternative definitions showing that the same result we were looking at when we look at other definitions. So those are the main changes, and they have been mainly due to several interactions with both academics, the public sector, and EJ advocates that have tried us to challenge what we have done and try to look at what is actually happening.
That's a great story of the benefits of really strong peer review. In fact, it sounds as though it sharpened and strengthened the findings that you originally had, and yes, even more clear. So excellent, and it's great to see a process that works that way, right, with the original paper and then the revision. So kudos to you and your team. What are your thoughts for future work? Will you continue this study or this type of study with added dimensions, or will you pivot in a different direction?
So we're actually trying to understand how the energy transition is going to look like and how we can achieve an equitable energy transition in the case of cap and trade, in the case of California's climate policy. So what we're trying, our future research is to look at different aspects of the energy transition and how to achieve equity with these other climate policies that have been proposed throughout the state. And indeed, since now I moved to Arizona, I am also trying to incorporate apply my research to Arizona projects and try to examine how the environmental disparities look like in Arizona and how we can, what policies are out there that could decrease those. So I'm still interested in climate policy, and I am actually learning a lot from your series as well on how on other researchers trying to look at these transitions as well.
That's great. I'm intrigued. Can you talk a little bit about, are there any examples you can share about what elements of the energy transition that you're interested in looking at?
Yeah, so one of the things that that I'm interested in looking at is how different energy policies could affect energy prices and how this might affect disadvantaged communities in Arizona. So we know that Arizona experiences very extreme weather during the summer, and indeed, if you have been there, you have experienced it. It's really hot, and trying to look at different alternative price measures that could reduce the electricity bills of disadvantaged communities. That is one of my main projects, because even though many of these energy transition policies can decrease the prices, all others could increase the prices that folks pay, and we're trying to look at which ones may increase it versus others.
Great, looking forward to that work emerging over time. So one last question that I would want to ask. You indicated in your findings that what you found was a 3 to 9% reduction in emissions, right, as a result of the cap and trade policy, at least from within the context of your sample, right, the sample that you brought it down to focus on cap and trade. Is that more or less than you expected? You know, how does that compare with measured impacts of other cap and trade policies? And how would you, how would you characterize that in terms of the policy impact that we want to see? Is it worth the effort? Are there other policies that that could have similar or greater degree of impact?
What we find is looking at only emissions, not only looking at, we are only looking at emissions on the regulated facilities. Therefore, what we find, it could be smaller than what it actually happened. But again, this can be harder because of other complementary policies. This compared to other, so EU ETS has also decreased emissions a lot, and I think the effects are comparable. However, what we cannot tell about this particular setting is we can only compare before and after, which means cap and trade versus not cap and trade before. It's very hard for us to try to analyze what would have happened had another policy taken place. What we do see is that cap and trade can have some efficiency gains compared to other standards that can be more costly to implement. And indeed, there's research showing that some environmental standards are very hard to implement. And yeah, but it's a very good question. It's very hard to know what and other policies could have decreased. But yeah, I think that as we move forward, trying to look at other climate policies, given that other states have been implementing other climate policies, it will be easier to answer that.
Thank you very much. So I think the answer, I would sum up your answer as saying it looks like it's having an impact, but let's stay tuned, right, to see what else we can develop in terms of measuring the emissions, which is just one aspect, obviously, of actually measuring the impact of the policy, right? So, so great. So thank you so much for your talk with us today and for sharing your work with us. We really appreciate it, and hoping to continue to get the word out there about this paper, but as well about the other emerging research that you're doing now that you're at ASU. So,
thank you so much.
You bet.
Thank you so much for having me.
Totally our pleasure. And so, Stephanie, we could put up our last slide. We will just do a quick promo for our upcoming events at the Irving Institute for Energy and Society at Dartmouth College. So coming up next week, we have the third session in our fall series on buildings and energy, which actually looks at the process of retrofitting the Empire State Building, which has been a huge and ongoing project of doing energy efficiency retrofits. So tune in on Tuesday at 12:15 for an update on that process. And then Wednesday, 2 weeks from now, I think, yes, 2 weeks from today, the next in our new energy series will be Paige Weber, another economist, looking at energy equity impacts of markets for clean air. So another angle on some of the conversations that we've had today, and she's at UNC. And then finally, Tuesday, November 2nd is the fourth in our Building Energy series, where we will be joined by Dean Alexis Abramson, Dean of our engineering school here at Dartmouth. She's chairing a panel on tools to accelerate carbon-free building and addressing the energy impacts of our built environment. So we're looking at finance tools as well as technology tools and policy tools then. So tune in for those events later on this fall. Appreciate everybody being here today. Thank you so much for your attendance, and stay safe, be well. Thank you again.
Bye.